Hello and welcome to episode 121 of the HamCorp Training Manual. In this episode, we set up and automate grade 7 water. It's actually not that bad. We also craft the first optical processor, the first circuit of the optical line, which is the final circuit line in the game, for now. Oh man, this is gonna get really cramped. Look at this. This is going to fit here, just about. I wanted to put it here, which made a little bit more sense to me, but it's too far. This thing has a max range of 32 blocks to connect to, so I had to move it here. This waterline is very lawn-basey and kind of hideous, to be honest. I think pretty soon I will do, well, I don't want to say pretty soon, but at some point I will do a waterline building. But first, I think I would like to make the grade 8 water multi as well. Then I'll have a better idea of how big everything needs to be, and then I can build a proper waterline building. I'll have to rewire everything, which will suck. I'll probably find some way to clean this up as well. For now, let's build the grade 7 and get this automated. Nice. While this looks really cool, honestly, it was not that fun to build. Because of all the curves and these floating blocks, it was a little less exciting to build than I was hoping. But it looks really cool. Now, let's go over how this thing actually works. So, at the start of the operation, the degasser control hatch will output a redstone signal. That is this hatch over here. And it's going to output the signal, and the strength of that signal is what's important. So remember that redstone has a signal strength between 0 and 15. So this one's 15, 14, 13, 12, and it goes down by 1 with every block traveled. The numbers 0 through 15 can be written as a 4-digit binary number. So 0000 would be 0, 1111 would be 15. You know how binary works. Now, based on the strength, we convert that strength into a 4-bit number. And based on what bits are 1 versus 0, we need to do different things. If bit 1 is on, then we need ozone sparging by inert gas. I need to insert one of the 4 noble gases into the machine. And to determine what gas I need to insert, I need to interpret bits 2 and 3 as a 2-bit number. So for example, the number 0111, which corresponds to a signal strength of 7, would require ozone sparging by inert gas, and bits 2 and 3 are 1 and 1. So that corresponds to 3, which means I need to provide xenon. Bit 2, superconductive deionization. If bit 2 is on, I need to insert 10 ingots worth of molten superconductor base. I can use higher tier superconductors, and that gives me an output boost, so it's good to use the highest tier that you can reasonably afford. For me, I think to start with I'll be using UHV superconductor base, but as I progress through the tiers, I will replace it with UEV, UIV, or UMV. Bit 3, gravitationally generated differential vacuum extraction. If this bit is on, I need to insert 4,608 liters of molten neutronium. Pretty straightforward. I think that's half a stack. Bit 4, the Seldonian settlement process. If this bit is on, disregard all other bits and don't insert anything. So for the number 15, for example, that would be 1111. Because the 4th bit is on, I don't need to do anything. Finally, for 0, or if no bits are on, I need to provide 10,000 liters of supercoolant. The recipe only succeeds if the signal is decoded correctly, and inserting any fluid not requested by the signal will void the recipe. So That is to prevent me from placing like a stocking input hatch and just stocking everything and hoping that this will intelligently take only the materials required. So I cannot do that, which is good because that would kind of trivialize this whole thing. But now what I need to do is to make basically an encoder or decoder, one of those. I need to convert this redstone signal into a 4-bit number, and based on the number, I need to activate the deposition of those different fluids. I should also set up some kind of additional logic so that this machine is off when I don't have the materials to successfully put into the machine. So if I run out of superconductor base, for example, I don't want this to run because then I'm just wasting my grade 6 input water. So yeah, quite a bit of redstone logic to do, but I will figure this out. All right, it is set up. And honestly, it was not as bad as I thought it was going to be. So there are two components to the redstone logic here. I'll talk about this side first because it's a bit easier. So what I have here on this side is a bunch of input hatches and a bunch of fluid storage tanks. Each of these tanks has a different fluid, one of each of the fluids required for the process. So I've got supercoolant, I've got molten neutronium, molten superconductor base, helium, neon, krypton, and xenon. I have fluid detector covers on all of these tanks set to output a signal if the tank is more than half full. All of these signals are combined with a series of AND gates. So at the end, what happens is over here, I get a signal if every single one of these tanks has at least 50% capacity. They're all being supplied through fluid export buses and all the fluids are being level maintained. This signal now goes to another AND gate where it's combined with the signal for if I have less than 512,000 grade 7 water. So if I have less than that much and I have all of these inputs, then I'll put a signal. And this signal is what's used to actually turn on the multi-block. So the multi-block will only be on if I need the water and if I have enough inputs to make sure nothing goes wrong. So that's half of the redstone. The other half is on this side. So here I have an activity detector cover. I'll come back to that, but this cable goes around and reaches all the way over here. Here I have the degasser control hatch. It points directly into a bus converter. And what a bus converter does is it's basically 16 different cables combined into one here in this bundled cable. And the bus converter uses the strength of the redstone signal to send a signal through one of those 16 different cables. So for example, if the signal strength is 0, you get a signal on the white insulated wire. If the signal strength is 1, it comes out on orange. If the signal strength is 2, it comes out on magenta. If it's 3, it comes out on light blue, and so on. This is a really, really simple way to convert the signal strength into some kind of 4-bit number. Because this one is 0000, this one is 0001, this one is 0010, this one is 0011, and so on. Bit 1 is the digit on the far right, bit 2 is the next, bit 3 is the next, and bit 4 is the digit on the far left. So because bit 4 being on means do nothing, I only really need half of these. So every time I get a signal strength of 8, 9, 10, 11, 12, 13, 14, or 15, I do nothing. This cable leads nowhere and nothing happens. I don't really need to have this cable here, of course. I can just destroy it, but yeah. As for the rest, they are organized like this. So the lowest is on the right, the highest is on the left. This is 0000. I just looked at what do I do if I have no bits? And the answer is I add supercoolant. However, a little quirk with this bus converter is if there is no signal, or I guess it's not a quirk, it's a feature. If there is no signal, aka a signal strength of 0, then this insulated wire turns on. But I don't want to keep supplying coolant unless the machine is also running, and that's what the activity detector cover is for. So if the machine is running and I have a signal in this white wire, then output coolant. That's the logic, basically. And then I pretty much just went through every single bit combination from 0000 to 0111, and I turned on the different kind of valves on the other side based on that. So this one, 0001, means I need to output helium. 0010 means I need to output superconductor. 0011 means I need to output both superconductor and neon. So I have these two wireless connectors here. The next one needs neutronium. The next one needs krypton and neutronium. The next one after that needs neutronium and superconductor. And finally, the last one, which is 0111, needs xenon, superconductor, and neutronium, all three. These colors, by the way, are fixed. A signal strength of 0 will always be emitted on a white insulated wire. A signal strength of 1 will always be emitted on an orange, and so on. You can see the order if you just search for insulated wire. And from left to right is from 0 to 15. So white is 0, orange is 1, magenta is 2, light blue is 3, etc. So yeah, actually not that hard. So I output these signals, and they go over here. And they go to a machine controller cover on these little buffers. And over here I have a fluid regulator. There is a maximum to the ticks amount you can put in here. It's 2048. But 2 minutes is 2400 ticks. So what I've done is I output half the amount every minute. And so far, that has worked perfectly fine. Another way to do it would be to turn this into a pulse and then output the entire amount in one pulse duration, but I have a little bit of PTSD from using pulses. I'm okay with this. This seems to work. I haven't had any issues. I don't know if this breaks on server reset. I guess I'll find out. But so far, this has worked perfectly fine. And if you want to troubleshoot your setup, you can always scan the controller. Here, for example, I have this one doesn't matter. As you can see, the success chance is 100%, even though it says not okay, because the fourth bit, which is the bit all the way on the left, is on. So I don't need to do anything. But yeah, grade 7 water. Honestly, much easier than grade 5, but definitely second place. It's not particularly hard if you know that the bus converter exists, but without this, this would be a real mess for me. And now I can make raw exposed crystal chips. This comes from optically enriched crystalline boules, which is a pretty simple recipe. It's just a UEV laser engraver with UU matter and an americium doped monocrystalline silicon boule. I also need a magnetoresonating lens, a phaelite lens, I don't know what that is, and a quite certain crystal lens. Phaelite? Oh, I probably have some. I can get it from a meteor or I can get it from Ross 128b. Okay, it's just a random material. Then I can cut these into photonically prepared wafers, UEV recipe. It needs grade 7 water at least. I can then laser engrave to get photonically enhanced wafers, but it needs glowstone nanites, a solar light splitter which is not consumed, tin plasma, and oganesson. I have a bit of oganesson, but I could make more through fusion if I wanted. The solar light splitter is pretty easy to make. It basically just needs some irradiant glass panes. And the glowstone nanites, this needs ASOX, a redox polymer lens, 50k UU matter, and 8 double compressed glowstone. So that's a decent amount of glowstone that's going to be going into this. But it does make a stack at a time, and I use one at a time. And finally, once I have the photonically enhanced wafer, I can do this recipe, which I think is just worse by a lot, because I need a fluxed electrum singularity, which that's a lot of fluxed electrum to use, especially when the alternative is a forge hammer recipe. It gives me half as many raw exposed optical chips, but it doesn't need a whole singularity. It just needs a little bit of grade 7 water. So, let me get that done. Next up, I can download some more RAM and make optically compatible memory. This requires the space assembler so I can finally use it. The higher tier recipes are obviously better, but right now I only have access to this one. Need some tier 3.5 memory, which is easy to make, and some other stuff that you've seen before. I also need to make an optically perfected CPU. Well, I'm gonna have to make thousands, but this is all materials you've seen before, except there's also an optical CPU containment housing. This is made in a UEV forming press with the optical circuit board, botmium, nickel zinc ferrite, aquata alloy, vibrant alloy, and bedrockium. Pretty easy, just need to upgrade another machine. That's it. And the space assembler automation is really simple. It's just like any other multi-block. Input, output, done. And now, I can finally make optical processors. This is done in a circuit assembly line, which means I need circuit imprints, of course. And basically, I just need the optically perfected CPUs, the optically compatible memory, optical SMD capacitors, optical SMD diodes, optical fiber cable, and enriched holmium bolts, along with mutated living solder. The first one, of course, needs to be done in a single block circuit assembler in a clean room, which is what I have here. So I'm going to make one, slice it, and put it in a cal. And because of this EU per tick value, I can quad share the cal. Perfect. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we finish off the rest of the optical line, all the way to the optical mainframe, which is currently the highest tier circuit in the entire game. After that, we will look into Mark IV compact fusion, eternal singularities, and dimensionally transcendent catalysts. See you next time.